Hello.
Hello. Hey, everybody. This is Ardis Kadiu, your host of Generation AI. And with me today, I have JC Bonilla. Hey, JC.
Hi, everybody. Happy Friday and excited to be doing a live session today via LinkedIn. All of your LinkedIn friends, followers, Element, family. Hello. And it's finally raining in New York. So I'm really excited. Never been so excited about rain. We can talk about drought, but we have a special thing today, artists. We've been talking about this for quite some time, and we finally cracked it in Element. Can you tell everybody what's happening today?
So we're going to talk about application fraud detection and application fraud, specifically around colleges and universities. So college application fraud. And we've been thinking about this for quite a bit. We talked about it during some of our other episodes, but we figured today would actually go a little bit in more detail around like what the problem is, and then how Element is solving that problem. And we're going to invite in one of our co-hosts, maybe, or special guests that we've been having now on the podcast for a couple of times on these live shows, to give us a little bit of a deeper dive on the technology. But let's JC, let's invite Petar in, and then we can get started and give folks some context here.
Awesome.
Hey team, happy Friday.
A friend of the podcast, a co-host, and our CTO. Petar, how you doing, my friend? This afternoon for you, morning for us here in the US.
It's good. It's a nice day. It's actually snowing here. It's we are getting ready for Christmas.
I so want to talk about the weather, but we need to talk about AI-powered application fraud. So let's jump into the conversation, friends. I would love for you to paint the picture, both of you, of what is the problem that universities are having today on applications fraud, so then we can start basically walking down to the technical aspects and how Element has solved that problem. But let's start with the outset. What is the problem the universities are seeing with fraud?
So one of the things that for a lot of institutions, applications are traditionally been for selective institutions. There is a payment component to those applications, so you have to pay a fee in order to submit that application. However, as part of non-selective institutions or four-year open enrollment institutions, like community colleges, you don't have a fee as part of that application. And whenever you apply to a school, if you get admitted, that admission happens really quickly, and that triggers off a lot of different components on the on the other side. And a lot of those components are around getting an email, a .edu email that gets provisions for you. You kind of go through the system of getting an account and so on and so forth. So what we're seeing from our side and what our partners are seeing is, number one, they are seeing a huge increase in applications that are non-real folks that they apply just to get these resources or those .edu accounts, and then now they can use them for free licenses of a Microsoft Office or other account or other kind of platforms. That is not the only thing, though. So yes, getting the free resources is one part, but also the driver for these fraud applications in some cases is around financial aid or funds that you can get awarded. So as you go through the application process, you can submit your application, you get admitted, but then you just don't show up to class, but you collect financial aid funds that have been now granted to you. And that's a huge burden on the institution. And that's so we have different levels of fraud when we talk about this. But all of those are hugely impactful for the school side.
So Ardis, you're talking about, look, this is a behavior that is happening, and the manifestations and the cost that is taking place are enrollment strategies, financial aid, resource stalling. So literally as they come in, they manifest in multiple ways within campuses. Can we talk about how they come in? Like, what are the most common tactics today that someone can target a school and, I guess, fake this application and play with the admission systems today? What are these common tactics and how a fraudster comes in?
So one thing that we saw, and kind of like people would think, like your first guess would be like, hey, okay, they might be using like automation first, right? That's kind of the lowest way of actually trying this is actually writing kind of actually programming code that will go in and kind of like mimic a user and just generate random data. That's easily captured like using a reCAPTCHA, using like honeypots. There's different ways you can do that. However, because they see such a huge upside, right? They saw that even if, hey, if I'm filling in manually one by one, I just need to be accepted one. I'll get more money than if I were for my time invested. So you cannot use any like bot detection mechanisms. And one thing that they would use, they would actually try to use real data as much as possible. They would find a person, they would try to do like an identity theft and try to provide data of some other user, or try to kind of like find data that's similar and just change little parts of it. That'd be just, randomize, hey, where I'm at in the world, try to use a VPN. So I'm kind of like coming from a different IP address that mimics that I'm actually in that location, and just like try to do different type of first name and last name. So using these techniques, it's really hard because the data, when you take a look at it, it actually looks real, right? From the first glance, and for the reviewers, if they take a look at kind of the summary, it looks real. So they would spend a lot of time actually looking at it before they actually can see that something is wrong. So you need different strategy. You need different strategy to detect it.
So Peter, you're talking about a sophisticated scheme. We're not
Yes.
talking about, hey, I'm just gonna create a second application on my behalf, and I'm gonna, though that could be taking place, we're talking about cyber attacks, to use a different word, cyber fraud, and the machinery that comes with it. So fast forward to AI, guys. As AI experts, we know that there's a movement in AI towards cybersecurity. So let's just paint the picture very, very broad so we can go down in super detail on how we address this with Element. But with the rise of AI generated content and automation tools, how are we getting inspired that this is an AI problem for us to tackle, and then there's other places where AI has solved this? I guess my question is, just paint the picture about AI in the landscape of fraud detection. What do we know? And then also you guys say, we're gonna do this in Element.
So maybe we can talk a little bit about like what we're seeing, like how people are solving this today, or like what is the manual intervention,
right?
What's the like how schools are dealing with these fraud applications today. And Petar, you can go a little bit deeper in this one because you have a lot of examples that our partners have come back and said, hey, we're doing this manually. But essentially what they do, what our partners do, is that it's a very manual process, and it takes a lot of time, it takes a lot of effort. They're reviewing these applications, but they have come up with certain heuristics around, oh, we see certain IP addresses, and like we're going to blacklist those IP addresses. We see names that don't really make sense, or we see students have submitted applications at certain times that don't make sense. So they're really one by one reviewing the applications or the data that comes along with it. And it's very, very time consuming. In some cases, they built in like filters or segments that can they can capture them, but it's one dimensional. It's usually one dimensional or two dimensional.
Right.
Like they look at one or two things, and it's very time consuming. And a lot of them just go through. So that's how they're solving it today. And what we're getting feedback on is, hey, it's just becoming overwhelming, right? This is
overwhelming,
way too much work.
And probably always 10 steps behind, right?
Right, exactly.
Catch up, yeah. Anything from you to add there?
Yeah, nothing special. I think Ardis covered kind of like the main gist. The whole problem is like you have a lot of applications to review, especially now that the application season has started. Right? So even if you have 100 today, it's really hard for you to have like a process that you will actually check against all the different components that you need to check. And you need to hurry. You want to review applications as soon as possible. You want to potentially admit those students as soon as possible, the legit ones. So it can be hard. It can be hard.
So, this is where we pivot into how we've solved that through AI, and the picture that we're painting, right? For those of you who are coming in late, application fraud is a thing with multiple manifestations on campus, and it's an AI problem because it's about pattern recognition, right? There's a pattern. It's about a ton of volume, right? And there's this aspect of the nuance in how it changes and how always basically staying ahead. So really interesting place for AI to do its magic. So within Element, we have something called Bolt AI. Can we just take 2 seconds to explain what Bolt AI is within the Element, CRM platform, and then how specifically we built a fraud detection engine and what it's doing. So, what is Bolt and how is this working for us?
Yeah. So Bolt AI is essentially, it's our umbrella AI in Element. We're talking anything that's AI powered. That can be predictive AI or can be generative AI. So Bolt AI is really the everything that kind of run any of the smart applications or smarts in Element. Now, before we get to like the actually how we're solving this problem, like or maybe we can talk about that, but I would love to talk about the factors. So it's like, how are we thinking about this? So remember, we just talked about the different factors, the IP addresses that somebody looks at. This is really important because we have over 10 or 12, I don't know how many, but we have a lot of different factors that we are looking at. And I think that's probably one of the
Sure.
more kind of
So, Ardis,
like
but
the best thing
that's
to
the
go
conversation.
over right now. Yeah. So
Right,
Petar, maybe we can go through that because that's very, very important in what we look at. And some of those factors can be, just based on data that we have from the platform. Some of them we can look at, IP addresses. Some of them can look at address, so there's a lot of those different factors. So the AI here, we'll talk about, how we put all that together, but focusing on these factors is really, really important because it's kind of a unique way to think about it.
Yeah. So how I would present this, if you're thinking about it, think as a human, right? Think, what would you do if you were presented at this and you need to solve it? Well, what would you look at? And then that's kind of how you start, right? So what are the types of behaviors that you're detecting? Because Element is an engagement platform, it's uniquely situated that already collects a lot of the data of the behavior of the users if they're filling up their applications. So we can use that data. One of the most important things is, hey, we don't want to bias this decision, right? So we just try to focus on the behavior and kind of like some physical aspects of kind of like their application. So one of the things that we saw is really helpful is we might see that a fraudster might try and submit many applications in sequence and do it really fast because they are trained to do that, right? They will do it once, then next time they already know what to enter. So kind of like measuring that time to completeness can sometimes be an indicator. Some other interesting aspects can be, let's try to actually detect, is their IP address coming from a VPN?
Yeah.
In most cases, fraudsters do try to use a VPN to kind of like to kind of switch their location. Yeah.
Hey, Petar, can we go a little bit deeper on those? So each individual factor, because I feel like this is really important for the audience to understand exactly like what they are.
Maybe take one step at a time. So with the factors, there's the timing indicator. You mentioned speed of submission and time anomaly. So explain that a little bit.
Sure, but time to submit is as it says, right? How much it took you to actually submit that. That's what we want. One of the components that's important. And also,
why is that important?
Looking at the historical, because if you are filling it really fast, right, and then you're doing it, that generally sounds that you're doing something kind of like trained on, right?
An application could take on average 45 minutes. All of a sudden, you get 45 seconds of an application. Like, so know there's a machine, right? Or
Correct.
What about
somebody
when it
who's
gets
copying
done?
and pasting really fast,
Copying and pasting, right?
Yeah.
So a bot. What about when I do it? What if the application is done at 3 a.m. Versus noon?
It's an indicator. It does add to the score that we're calculating, but it's kind of like a lower score because sometimes students do tend to submit that after midnight. But it is a factor that should be taken in, especially if you see that the student generally was active in other times of day. If you see that those discrepancies. What's really good about Element, because you have also all the historical data. We have all the applications that we submitted before, so we can compare against that as well and get like, hey, what's the average time to submission? Is this much faster than the others? What's the average time of the duration, but also the moment in time? So that there's you can use timing. That can be one of the factors. And some other factors is as we mentioned, the historical part of Element is the actual duplicate number of applications, right? So because your Element is a huge platform, we have a lot of schools, 250 partners right now that submit applications. You can actually see, hey, is this potentially a duplicate across the system? Are you seeing that currently they're trying to apply to all these schools, or just to that same school applying multiple times? That can be a factor that shows that something is going wrong, right?
Specifically, that means is I just basically use all my biodemographic academic data and I basically replicate it 100 times, so it looks real. But what is changing is JC1, JC2, JC3 at maybe at the email side or something that makes it unique. But when you look at the bone of the application, it's all the same. That's what you're talking about, right?
Correct. You might see like on a specific school that one fraudster would try and submit 10 applications with
Yeah.
kind of like only one character variation in their email, right? So that's a factor that needs to be taken into consideration. In terms of going forward with kind of the emails, there's more factors to just the email aspect. As we said, the email can be used kind of, you might be using a disposable email, right? You have all these providers that's kind of like a one-time email. You can use it in a month, discard it. So that immediately shows that something is going off, right? In most cases, if students are applying, that's really important for them in their life, right? So they will probably use their private and personal email that they probably have for a long time. So it'll be probably Gmail, Outlook, and something that they actually use. So having emails that are kind of disposable, having emails that had bounces before, that indicate we use kind of a global database of all bounces, right? So you're able to detect that, hey, a certain email got bounce, not even for element communications, but across the world. So that's able to signal us, hey, is it actually a valid email or not?
Peter, for those schools who are still doing this manual or the how does the AI think? Phishing scams, usually they give you an email or some type of link that you click through and it looks almost the same, google.com. But what happens is it changes google.io or something like that. And then what you see is that the identity email or the URL, it's fabricated, but to
Right.
the eye, human eye, it looks the same. Is that what you see on these email fabrication things, that it looks the same, but all of a sudden it's just small changes to our human eye when you're reviewing 1,000, then it's impossible to capture?
Correct.
Is that what it looks like?
Correct.
Interesting.
And if you try to send an email to that email, it'll bounce. It will not go anywhere because it doesn't exist actually.
Yeah. So we take into account the bouncing. So that's really important. Like this is something that it's not that the email is valid, right? Because it looks valid, it seems valid, but once you verify if this is a real email, it happens around the bouncing, or is there a server on the other side, and so on and so forth. So that's really, really important as well. And then I think that is probably something that's overseen quite a bit and not used a lot, the bouncing part, because it requires you to actually send an email over and identify if this is real or not.
So thus far, what I'm hearing from indicators that our AI will be using, there's looking at the application as a time unit, right? So when it gets submitted, how often, the time it took to submit it. There's the aspect of the application as a piece of text, the information that is within and we're capturing. And I'm gonna say the I'm hearing like the metadata, like the email, the identity, the comms that defines the
Just one
application. You said
just
something
one
about
correction. We don't use the application information. We try not to use that. We only use maybe the email, phone number, address, but not the bio and demographic information. We don't want to use the demographic information because that could introduce bias.
We'll talk about that in a little bit, right? So, but you mentioned IP. So, what can we say about location as an indicator? What are the heuristics, the patterns that say that's going to be important?
There's a lot. If the IP is changing, right? If you see that, for example, a user accessed the system through 5 to 6 different IPs during their kind of session, or it can be a longer session. If they take 2 days to submit the application, they might be changing. So that can be a signal that something is off. They're either changing locations or they're using a VPN to switch their IPs constantly. There's also, based on the IP, most of the VPNs are known, and you kind of like know their IPs. So you're able to figure out, hey, are they coming from an anonymized connection? In most cases, that does signal, again, something could be happening. So it's a factor that you need to take into consideration. And there's also just with the IP, you can also geolocate the user. So if you're able to geolocate the user, that also gives you some patterns, right? And the most common one is, well, the student is, I say that I'm from, for example, from Serbia, but my location right now is that I'm in Africa, right? So there's a big discrepancy there. So, okay,
By the way, very likely, Petar, very likely location mobility, right?
True. But it's something to take into consideration, right? Especially if you look at scale, that can be a good indicator. And it also gives you a really important signal because Element is a admissions platform as well. It contains like an online application. You can mark applications. Hey, these applications will accept international students or not, or just domestic ones. That gives us a lot of help, because if we know that application accepts only domestic students and somebody's coming, from Africa, that's really a signal. Hey, something is going off. Why are these students actually applying? We probably need to up the score based on that.
Yeah.
And Petar, Ardis, tell me something. How is this not heuristics? Basically, the good old traditional rule-based systems that we just say, hey, this is the behavior, so I'm just going to automate them, right? So where's the AI here? And so we can start moving into how all these indicators are
That's a great
orchestrated.
question. So traditionally, and there's already companies in the market that actually do application fraud detection. We decided to do our own as well because we want to explore this topic, and we think we could do a good job there. So traditionally, you would actually build your own machine learning models that would actually kind of train it. It initially would start with heuristics, but it's really hard for a person to figure out all the different scores. How do you add and decrease, based on all these components? It's kind of like your opinion, then you're introducing your own bias. So it's always best if you can just, kind of like output, say, this is application, it's fraud, it's not fraud, it's fraud, it's not fraud. And then you extract the features, and then you just pass the machine learning model to do that for you. That's kind of the most cleanest way to do it. So that's what has been done traditionally. We decided to do a little bit different approach with the advent of large language models starting last year, right? In the GPT-4, we saw that these large language models do have a certain capacity of reasoning, and that you can utilize that, especially the models that are kind of like at a higher scale. So we were thinking, well, this is kind of like as a human would reason about, right? You have all these different components. The only hard part from a human is to do this consistently, follow this process to evaluate all these steps. Well, LLMs do not have that limitation, right? They do not get tired. Their focus is always on. So we're saying, hey, what if the LLM is actually doing the kind of the reasoning against all these steps, but we give it some more explanation, some more prompting, and that also gives us a really interesting feature, and it's something that our customers love, is because the LLM would actually go and take a look at all the features and kind of try to understand what's going on and try to compact that into kind of like a final decision. You get a big chain of thought reasoning, which kind of like explains why it decided that something is a potentially fraudulent or not application, and exposing that to the end users. There's no magic, right? Everything is clear. It's like a human would think through a problem.
Is it possible to take a look to kind of look at an example? I know that we have a lot of live folks in here just to see what this looks like from our side. And as Petar does that, I did want to mention, all of those factors, there's additional factors that go into this that we've added in. Things like, for example, we utilize those IP addresses. There is services that are dealing specifically with like fraud IPs and other things that we pull information from. So we don't just use element data. We use other services that can give us much more intelligence, like the email fraud, for example. Like we use our services that are specifically geared towards giving them the email and verifying if this is valid or not. Phone number verifications, we use our phone number verifications where if the number is valid, what kind of number it is, and so on and so forth. So all of those pieces come back, and each one of those can technically be a really, really good, strong signal and heuristics from the school side that they can filter on. But like Petar said, we want it to be even better. So we are running all of these different factors through these large language models that Petar and the team has. It's kind of running through, and the reasoning is really, really good there. Do you have that available, Petar?
Yeah, I'm sharing my screen right now. Can you confirm you're seeing it?
There you go. Seeing it.
So this is kind of like the in element we enter. This is where you would actually see all your applications that are incoming that you need to review. And then we show them, you can filter for them, but we show, hey, this is a high risk potentially. So let's take a look what's going on. You have immediately a banner where kind of like you as a human, if you're validating, say, hey, this is actually legit, you can mark it as legitimate, or dismiss the alert if you don't want to make any changes. This is really important because this is where our customers can give us feedback so we can refine our algorithm. We can do this at scale. So just kind of like an FYI, we already processed around 60,000 applications since we released this. So we already have a lot of data to actually refine.
And this has only been a couple of weeks, right? This is
just
and 59,000 of them are fake. I'm just joking.
So this is now the kind of like the difference compared to kind of like the traditional approach of solving this problem, right? In the traditional approach, you would just get it's high risk, medium risk, for low risk. Like you don't have explanation why.
That's the reasoning component of AI. So everybody, what you're witnessing is reasoning, when we speak about AI reasoning, this is the manifestation of how it gets surfaced to us users and how we will consume it. So, and by the way, for those of you who follow us in this podcast, this is one of the most exciting contributions of the last batch of LLM frontier models. This was not available a year ago, type of thing, right? So,
Yeah. Yeah, this is really exciting. So one of the things, as Petar kind of shows us a little bit more, but what gets me really excited about this is that we now have a system where we can introduce more components, and the system is explainable. So these machine models are usually not explainable. They can't tell you why they reasoned about a different way or why this is fraudulent or not. So now we have explainability, but also we bypass the cold start problem. So originally we would have needed so much data and human annotators to say this is fraud, this is not fraud. So we needed a lot of data to kind of pull that together. Whereas now we can start right off the bat, and we don't have to worry about if we have a large data set to kind of train what's called a traditional ML model around this.
Yeah. What I love to do is, let's just recap a little bit so we can then talk about how it is orchestrated, because this is an anomaly detection type of use case that AI does really well. And one of the things that happens when you orchestrate, and I'd love for you guys to explain about how it comes together, is that a high risk label, which is how we decide to personalize it, can be given to the real deal, right? So in this idea of how we start introducing and thinking about fairness of evaluation, we are bringing so much machinery and potential automation here to our consumers and partners. But there's a really important, thoughtful aspect that pushes element in our technology. How do we do this the right way? So what we have is all these indicators that, humanly speaking, it's impossible for you to do at scale. With AI, it can be done at scale. And as you mentioned, Petar, we already looked at 16,000 and like, come on, give me 6 million more, no problem. And it's very good at not looking at specifically look for these IPs, but rather there's a structure, there's a nuance on the IP, and LLMs and AI kind of fills in the blank and goes really ahead of you. So we've seen that emails could be a source, an indicator of fraud. But what is the structure and the evolution of the next generation of fraud emails? It stays ahead of that. So all that gets instrumented. How is all this put together? Is it a score? And then how do we start thinking about what is good enough for us to say high risk or not? And then third, how is this a fair evaluation type of thing, right? And bringing it to the responsibility of doing this the right way. So can we brief a little bit about that?
Yeah, I'll take the last one, right? It's like, how is this a fair evaluation? Or, I mean, Jesse, you and I have talked a lot about this idea of fairness and explainability of models.
Yeah.
So, that was our primary driver.
I'm leading the witness here, okay?
Of course. So when we think about as the partners were coming to us and they were kind of explaining what they were doing on their side, like what were the heuristics that they were using to identify these things? Yes, can we build an ML model? We can, but there's no explainability behind that ML model. So when it gives you a score, it's going to give you a 1 or a 0 or whatever it is, or anything between 0 and 1, right? The probability of this being, and then you have to kind of categorize them and do all the things. So that's a traditional way. But if you put a human in, that human can now has some heuristics, has some background. They can reason about these different factors if we provide enough context of what is the importance of each factor, how it gets used. And then so we're essentially giving the large language models that are pretty good at reasoning, we're giving them a lot of context on each one of these different properties, right? And then we're telling the model, hey, reason through this based on this heuristics and give us a category, but also tell us the reasoning process that you followed. That is very, very unique. You can't have that with a traditional ML model today. The explainability is very low. So that is a huge unlock. And I feel that is even more transparent than traditional models, and perhaps even better at kind of pulling the nuances of the relationship between these different factors, right? So, I mean, from my perspective, I really appreciated that. And Petar, what would you say in terms of the capabilities of the reasoning models from that we're using? Like, is that something that you've seen? Hey, these models they just can't handle this right now, or like, tell me, like, why is this possible today versus, like, let's say 4 months ago when the O models weren't available and the O1 models weren't available?
I think it was possible even 4 months ago. I think it was possible. I think just now it's probably more cost effective as kind of like
Right.
the if you think about it now, intelligence is now cheaper. So that's the only difference that I would kind of like take away from that. But you could have done this 4 months ago as well. Like
6 months
GPT-4
ago?
Turbo as well. Yeah, even a year ago. Like GPT-4 could do this as well. It would just be really slow, and it will cost you a lot of money. Like the like during last year, like March, April, right? That level of capability. GPT-5 Turbo, probably not, but everything like for 4 and up was has a really good reason. And now it can only go higher. So you can expect, for example, with O1, when O1 gets kind of like maybe a little bit more reduced pricing, I think then that will unlock as well. Because this is a really good problem for O1, because O1 is like, hey, I need to think, and then give you an answer. So having that capability, especially since this runs in the background, right? You don't need to give instant feedback to the user. So it's a perfect use case. It's a perfect use case.
I love to ask one more question on the technical domain, so we can then take a step back onto practical implementations and how these basically changes CRM lands and operations in a mission office. But how, technically speaking, and this is a question for both Peter and you, how do you think about bias, right? In the aspect that in traditional models we talk about false positives, right? We could be much better at detecting email fraud than IP turbulence, to use Petar's, it moves it's like that signature. How do we think about that? And how do you start thinking also about when a potential misclassification of fraud takes place? As technologies, where does your head go there?
So from my perspective, I think that the kind of human feedback is the most important, right? To like
Human in the
large
loop?
language models are here. Yeah, large language models are here to stay, but they need to work with the people. So it's just they should do the bulk of work for you, so you don't need to spend the kind of like the time consuming part. But it's up to you to make that final decision. But the LLM, if it compiles everything and it gives you this, like it's a quick yes or no, that already like boils down. Because we try not to include the demographic pieces. I think that's really important because it's really hard to get bias out of just looking, hey, the time to submit, does your name match the name on the phone number as well? Are you using a disposable email or not? So these are like some of the characteristics that
Very smart.
cannot be reduced bias, right?
Yeah.
So that's how we're thinking. But in the end, we do not make any decisions. We do not build any automation on top of this further. Like, hey, if something is fraud, you immediately decline the user. We don't want to do that. We want the humans to decide in the end, hey, is it good? And over time, we'll see. Let's build the trust together. Let's see how it works at scale. Let's collect that feedback. The more applications coming in, the more data we'll have that we can refine. For example, one of the things that we will do for the giving feedback back, right now, you just say, hey, I confirm or I don't confirm. But what we will do, we will actually allow the users to actually enter the reasoning why they think it's actually illegitimate. So imagine now you have all the text from all those feedback and you have all the runs. And now you can take all of that and retrain and say, hey, fix yourself. Like, hey, here's the feedback and you should take that into consideration. Like, here's the feedback and you can then fine tune and get a really sharp model. So there's a lot here to grow.
Interesting. Ardis?
Yeah, I mean, I think Petar covered it all in terms of the bias. We try not to do things around demographic information or even PII information around, like, none of that stuff. It's all behavioral data. So as long as we have behavioral data, an Element is really good about collecting all those very granular pieces of information. And the reason this is important and why we did it is because we were having a hard time sending data back to external systems in order to do this. Like, we could not send behavioral data or any of that stuff. They're like very constrained in terms of, so it's like we have all this behavioral data and we understand that this is really important. So it's like there's features that are missing on the other side. So let's just build it in natively in Element. This way, we don't have to worry about the address verification systems or all this. Like the behavioral will tell us a lot about the in real time, right? In real time, you'll tell us a lot about what's happening and what it is. And this is just the beginning, right? So
Yeah.
we've been using this for other features in the past. The behavioral data, we use it for engagement scores. We use it for priority scores, for example, like when somebody, like, is this person like a hot lead or not, or things like that to prioritize. But it's always been in the effort of, we provide you this information, and then the school decides how to run their processes to basically make decisions on that. So like Petar said, we give you the scores, they can filter on it, they can build groups, they can build automations on top of that. But we don't say, we're not even going to show you this application, right? If it's fraud or not. Like that's not what we're trying to do. We let that human make that decision. Or if the school trusts certain things, they put them in a different bucket. They deprioritize in terms of review, or maybe they don't even move them to the SIS in order to create those applications until they review them further, right? So they can separate the work streams, and they can separate like how much time they put towards training and reviewing those. So
Let's Ardis, I love where you're going. Let's unpack a little bit of that. So the Element 451 via our Bolt AI brand of AI toolkits and tech stack has solved this problem of application fraud by deploying generative LLM, modern AI, looking at many of the conditions that we know are basically driving fraud, but taking a new angle that is not systematized or traditional decision models, but staying ahead of how crime, cyber attacks evolve. We basically, the technology keeps up with that, if not is ahead of that. The other component that is really important is it reduces bias, because the technical decisions that we made brings up data objects that in a way do not have the conflict of, it's going to be biased because I'm a man or from Costa Rica or whatever. And three, as Petar said, we designed these with a human in the loop AI approach, servicing a lot of the reasoning in these collaborative systems is kind of what makes this process go forward. So now a label is placed, and Ardis, what you were riffing is, my gosh, now this is real time, and the implications that it has is multifaceted. So can we just spend a little time on what does it mean, and how does it change to have a CRM that allows you to do that? And how does fraud detection real time changes the day-to-day operations in an admissions team? Because to Petar's last point is like, we don't kick out the application, we just surface that and then have these collaborative systems, I guess the humans do their part. So how do you both see the impact in admission teams in operations today?
Yeah, if you go back to what we said, that we were trying to solve the problem and what these impact to the schools. So these applications were going through and they were creating .edu email addresses, right? So that's number one. So the application was getting moved through and moving into the SIS and creating whatever automation it is on the other side. Now you can have two different streams, and you can put the high risk applications that surface, you don't have to move them right away. You can put them in a quarantine state, or you can put them in a quarantine kind of segment, and you can filter them out before sending them over. And then a human person can kind of review them and say, oh, okay, this is good, this is bad. And then the ones that are good can now bypass and move. So we reduce the risk of these high risk applications to automatically go in and create resources that are not, that are expensive and take a lot of time. The same thing happens for these applications that move into the financial aid component. So now we're surfacing these things up so somebody can look at it right away and say, okay, you know what, I can see that this is not a real person, and kind of surface all that. So that's the first workflow, and I would say it fulfills the promise of how do you do fast application processing or automated application processing without having the risk of these applications being fraudulent and moving downstream into your other systems, but how do you catch them and put them into a holding spot so there can be a human in the loop to evaluate them, right? So now
I like
you
it.
don't have to kill the whole process because you're getting so many fraud applications. Your IT or CIO says, you know what, you need to fix this. You need to review everything by hand because you can't send me garbage, right? The garbage and creating all the resources and everything else. So now it allows schools to move very fast, to make decisions very, very quickly, to automate those decisions and move a student very fast through that funnel. Because as we know, that is a huge part of kind of engagement and the ability for that student to move, to remove barriers very quickly to enroll and to move to the next steps. So they're not able to do that very fast and reducing the risk tremendously of having fraudulent applications on the other side.
Love that. What about you, Petar? Anything that comes to mind as you look at the applications, teams moving forward?
Yeah, one thing that, as we said, this is just the beginning, right? As just most of the things that we've built, like the first version is the first version, right? We tend to innovate, and I do see a lot of potential here for further automation. And that would be, for example, imagine that if we detected something is high risk, well, in theory, our system could ask for like a proof from the student that it's not, right? So just like hey, submit extra documentation, or forms that, hey, we need to capture some more information from you. Can you write these answers? That can work automatic, right? And that can be kind of like another staging area before it goes further. Just again, just having that signal, as Ardis said, the biggest problem right now is how much downstream work is created when this comes in. So making it a little bit harder, right, for that to pass through, that's really important. And you can think of it as you pass that flag across, that everything can change. That you have dynamic processes. Hey, if you need if you create a tasks for somebody to review the application whenever it comes in, well, the task can now be immediately augmented with more information. You can search for more information, find more information, give it more context. So there's a lot of automation you can build to make this even better. It's kind of easier for us from this perspective when this is running in our system. When we needed to integrate, it's always a little bit harder.
Hey guys, let's go into closing thoughts. I have two questions for us. Feel free to pick them or create your own. But let's do a round robin on how we close. But my head is going to, all right, this is exciting. What is next in the innovation of AI powered fraud detection? Super broad. Or what is next for Element? Like, how do we stay ahead, and where are we going with these type of things, right? So let's just do a little bit of round robin, and kind of where do you see next, general, or where do you see next, specifically looking into Element? Who wants to go first?
I can start.
All right. Let me guess where Element is going.
I already working on, so it's a little bit easier for me. Ardis needs to think a little bit more ahead. But there's a lot of things where you can improve the student experience, right? That's something we're trying to focus on both sides. So there's a student experience, the staff experience, but also the student experience. Some of the things that we are now experimenting with is a generative UI, like actually generating a whole UI sections that are personalized for the student, for them to explore based on their kind of interests and topics and their kind of intended program or program that they're currently studying. So that's something, as probably some people don't know, we released the Student Hub, which is kind of like a application where students can find all the information that they need. Everything is a single place, one mobile app, everything that they need. So imagine now we already collect a lot of the behavioral data. So from kind of which pages they're viewing, what links they're clicking, all the conversations they're having. Well, you can use all of that to create like interest, right? You can, hey, what are they interested in? What topics are they interested in? And you can then search the knowledge base and generate a whole UI sections that then surface that information to the student. Hey, we saw that you're interested in this program. Hey, here are the potential salaries for certain jobs that happen after this program. That type of stuff. But imagine not even think traditionally for these types of systems, you need to prepare all the data up front. Like a lot of static data you need to update every year as things are changing. But with AI, it's kind of like a human where you can go in and search stuff and compile for you. That's something that we're experimenting with. And another thing that what we plan to do, and Ardis, I couldn't let of this for you, but I want to say this, is something that we have been mentioning for a while is the proactive part. We see that's currently underutilized across the industry, having proactive AI. Right now, if you think most of the AI is reactive, something needs to happen for AI to respond or start. kick off. So we're thinking, what if we inverse? What if you had AI constantly running and trying to detect what needs to happen? And kind of an example would be, hey, what if you have a kind of like imagine a student submitting a inquiry form, AI detecting that, right?
Right.
And then plans out the steps it needs to do. For example, try to enroll that student in. So that's the part that we think is really interesting, like planning out dynamic workflows, personalized, and actually executing them for a longer period of time. So that's something that's upcoming.
And all is coming to you next week, by the way. No, I'm Petar.
No,
Not hard.
These are very hard problems to solve, and this is very, very, very difficult kind of architecture. It's not just the way, it's not just some wiring here, right? This problem is very difficult, and just like we said, like how do we build all these different factors? That reasoning capability, that's the secret sauce. It's like how do we have built a library of all those interventions? How do we build the library and the reasonings and the planning around all of these different things? So that's something that we're working on right now, and something that we're planning around on this feature. So it's really, really exciting. It's going to have a huge unlock as we move to more autonomous agents and the world of we call it proactive, but obviously the agent world, right? The AI agent world. So
for me, as in closing thoughts, we have been governed by the fear of garbage in, garbage out, and sometimes we use it as an excuse, like I cannot do my applications or my data because I have all these fraudulent applications or bad data. And what is exciting for me is that slowly and steadily we start seeing AI carving out of those things, and things become better. So to the statement of data integrity, as you go downstream, and Ardis used that point, you can go fast without the fear, like there's bad things in there. Can I say that word here live? I don't know. Anyway, there's garbage. So we now have machinery that allows us to basically remove that. And this is the gangster move. Remove it, and it actually gives me a whole X-ray, a whole examination of why and how. Because in the past, when you saw that, it's like all of a sudden I have 1,000 records, and now I have 995. 5 got purged, and they were bad, but you never know why and how. So there's really exciting thing. So it gives us the speed for processing with high data integrity and exposing this transparency. As for me, that's the exciting thing, that fraud detection and these kind of techniques powered by AI are ahead of us. So, all right, this is it. Those are all how you guys like me as an interviewer. Is that okay?
That was great. Yeah.
I'm enjoying
reading the witness and kind of diving into it.
This is so much easier. You guys have the hard work job of answering the questions. I just have to basically, repeat what you just said. I just summarize it. Is the best.
Okay. It's really difficult sometimes, because we tend to talk a lot. Keeping things short is important.
On that,
all right, everybody. This was great. Until next time, we'll try to do more of these live episodes. Petar, thank you for joining us. JC,
always.
I'll see you on the next one.
Bye, everybody. Thank you, Petar.
Generation AI is part of the Enrollify podcast network. If you like this podcast, chances are you're going to like other Enrollify shows too. Our podcast network is growing weekly, and we've got a wide range of marketing, enrollment, and higher ed technology shows that are jam-packed with stories, ideas, and frameworks, all designed to empower you to be a better higher ed professional. Our shows help higher ed leaders and professionals like you find their next big idea. They feature a selection of the industry's best as your hosts, like Jamie Hunt, Seth Odell, Jenny Lee Fowler, Brian Gross, and many of your favorite leaders in higher ed. Enrollify is made possible by Element 451, the next generation AI student engagement platform that's helping institutions all over the country create meaningful, personalized, and engaging connections with their prospects and students. Learn more at element451.com.